Well, good afternoon and good morning, everyone, depending upon where you are. I'm Jonathan Nally. I'm the editor of Spatial Source and Position magazine. Welcome to today's webinar, brought to you by Bentley Systems, in which the company will be outlining a complete survey and site design solution. Before we get started, let's just have a couple of housekeeping points. Firstly, the webinar is being recorded, so you can replay it later on. You'll receive a link via email after the webinar is over. Now, you're more than welcome to ask questions of the presenters as we're going through the webinar. Just type them into the question box accessed by the Q&A tab in the control panel at the bottom of the window. There'll also be a Q&A session at the end, so if the presenters don't get to answer your questions as they're going through, they'll certainly do so in the Q&A session. And with that, we'll get straight into it. So I'd like to firstly hand over to Dave Boddy from Bentley, who will give us the first presentation. Thank you, Dave. Over to you.
Yeah, thanks, Jonathan, and welcome everyone. First up, thanks for everyone for attending this webinar today. We know how busy everyone is during these times, so it's very much appreciated. We have got a lot to get through, so without further ado, let's get into it. So an agenda, we have carved out 90 minutes for this particular webinar. We will start with an introduction. The bulk of the presentation, though, will be focused on an example project where we'll work through some survey-based workflows, and then once that's completed, jump into the site design-based workflows. We will finish up with a summary of what we've just seen, and during that time, we will also include a special offer for all the attendees. Now, it is worth noting that it's worth hanging in there for that 90 minutes for that special offer. I'll have a colleague of mine step through the commercial offerings of what that's all about at the back end then. We'll then finish up with a Q&A right at the tail end there. But let's start with the introductions. So who are Bentley Systems? So Bentley Systems has been around since 1984. More recently, we went public. We've now listed on the NASDAQ stock exchange. We are a global company. As you can see from the image, we do have a strong representation here in Australia with approximately 120 plus colleagues based here in Oz. Our mission statement, as you see up the top there, is to provide innovative software and services for those professionals who design, build and operate the world's infrastructure. Now, in terms of applications that we provide a wide array of applications focused on various disciplines, whether they be utility networks, rail and transit, power plants, nuclear power, etc. Now, in terms of applications, civil applications, you may have heard within our industry applications that we bring to the market, those being Open Roads Designer, Open Rail Designer, Open Bridge Designer or Open Bridge Modeler. And these are really targeted at the high end. They're really targeted at the high end of the civil design footprint. However, we do also, now before I jump into that, you may also be aware of, though if you're not aware of Open Roads Designer, you may be aware of our previous civil design solutions, that being MX and Inroads. We do also provide another civil application, that being OpenSite Designer. Now, think of OpenSite Designer as the little brother of Open Roads Designer. It contains approximately 80 to 85% of the functionality of Open Roads, but it also contains a strong focal point directed towards those designs within that site or mid to smaller scale civil design areas. For the next slide, what I'll do is I'll pass on to Sean from Air Inspect Australia. Now, Sean is Air Inspect Australia's Business Development Manager and Chief Remote Pilot. So over to you, Sean.
Thanks, Dave. Thanks everyone for joining today. Appreciate you taking time. As Dave mentioned, we know everyone's busy. So a little bit of an overview about Air Inspect. So Air Inspect Australia started back in 2018 out of Southeast Queensland. we pretty much service the east coast of Australia at this stage, with an office in Victoria as well. Our core focus has been in asset inspection, usually high value assets, buildings, industrial portfolios and so forth. And of course, civil within construction, so surveying and mapping, producing 3D models. We naturally provide a high quality service for our customers, and we certainly look at safety practices and standards, which we do on every project. Next slide, please, Dave. Thank you. Just a quick overview on the services that we provide. So anything from gathering requirements through to customer reporting presentations. So as I highlighted, safety assessment and flight planning. So this could be any number of different drones that we use. You probably may see an M300 behind me there that we tend to use fairly often. From a data acquisition perspective, we'll look at different types of equipment, not only drones, helicopters, DSLRs, and different lenses. So for a particular job, we might use a mixture of those pieces of equipment, depending on the outcome we're trying to achieve with our customer. And then obviously processing that data. Naturally, we use Bentley's context capture product fairly heavily for our projects. And yeah, it's obviously made a big difference for us over the past few years. And then having all that data is great, but we have to work with the customer on how we actually, what type of analysis and visualizations. No point adding more data and going through thousands of images if it's not actually helping you in your workflow, and looking at the reporting side of things. Yes, if you need anything more information about us, probably just jump on airinspect.com.au, and we're more than happy to provide any more detail that you need. Thanks, Dave.
Thanks, Sean. So what are we providing today, and what are we offering today, and why are we doing this? So Sean mentioned in the last slide the use of context capture. So what we're offering today is we're offering a bundled solution set made up of two applications, the first being context capture. Now, as an application, context capture supports the mass data collection workflows. So within the image there, you'll see that we support digital photogrammetry and laser scanning. So the digital photogrammetry, the image there represents a drone, but it could be terrestrial-based photogrammetry as well. In addition to providing context capture as one part of the bundle, we're also offering up OpenSite Designer. So OpenSite Designer incorporates within its workflow survey capabilities. And I would say this is in support of the more traditional survey workflows and techniques, supporting those discrete data collection capabilities found within total stations and GPS recorders. So why are we doing this? We know today that the surveyors out in the field there have a wide array of survey sensors which they can deploy on any given project. And they may wish to deploy all these types of survey sensors on one project. So what we're doing is bringing together context capture and OpenSite with the survey workflows within OpenSite, bringing that together in a bundle to ensure that we can provide a solution that supports all those different survey sensors. But we want to add more capability to this. So not only being able to provide surveyors with the ability to create reality meshes or reality models and undertake feature modeling through traditional survey workflows, in addition to that terrain creation analysis. But we also want to provide ability to do and undertake sort of site design related civil works, whether that's road design, site design, drainage design, services, etc. So who does this benefit? we believe it'll benefit the surveyors who provide, a wide array of geospatial data acquisition services, and maybe have the capability or can source the capabilities to undertake some site design capabilities as well. Conversely, we believe site design professionals who provide civil design services will benefit from this bundled solution. And those who, again, may be able to source survey capabilities or maybe provide some in-house survey data capture capabilities. So they're the personas we believe this will benefit. And these are the personas we are targeting with this particular bundled solution. So jumping ahead now into the example project, and this will make up the bulk of the presentation today. Just to provide some context, the project is located in Caloundra on the sunny coast and will involve survey capabilities or survey workflows, including a drone survey and a total station survey. From that, we'll then jump into the design. And as you can see from the napkin design, or the design that was been drawn on a napkin in inverted commas, the project entails some widening on Ulm Street. So Ulm Street is that street on the left-hand side of that image, or that western edge. So on this particular road, there is some widening and curb and channel that needs to be placed in there. There is a new road, a greenfield road, that links Ulm Street onto the western side with George Street onto the eastern side. And as you can see there is also requirement for a new bowlo. So the bowling green, the clubhouse, and the associated car park. And we'll also step through those delivery requirements, plan sets and visualizations. And what we're going to try and do in the next 70 minutes is take it from that napkin design into a finished product represented on your screen now. So let's start with the survey-based workflows. And what we'll do is we'll start with data acquisition techniques, including what I've described as desktop surveys, digital photogrammetry, point cloud, and total station. Then we'll jump into terrain creation and analysis before proceeding down into the site design-based workflows. So when I talk about desktop survey, what am I talking about? Well, I think many out there would understand that a lot of agencies today, whether it's a government department, whether it's federal, state, local, or even those providers, those utility or service providers, do provide information that's freely available. This information is usually available through their website, and it comes in many forms. It could be through a web mapping service or a web mapping tile service, where you link into organization servers and stream that information down into your work environment. Or it might come in the more traditional manner through tab files or shape files, which can be downloaded and also consumed within your project workflows. And the type of information that's up there consists of a wide array of GIS information. And for us within a civil project environment, information such as existing services or cadastral information or survey control information is important. So let's step through a presentation here. So we're in OpenSite Designer. I'm going to work within the OpenSite modeling workspace here, or workflows. And the first thing that I'm going to do is open up our coordinate system, because I want to set the coordinate system for this project. Now, we do support GDA 2020, so we have the ability to support that geographical coordinate system. But in this particular project, it's actually MGA 9456. So what I'll do is I'll set that coordinate system, and that then allows me to stream in Bing Maps. So that Bing Map just provides me with that image background, that context around the project area. So once I've got that in and I've set the transparency to sort of diminish the Bing Map slightly, I'm now going to set up a connection into in this case, a Queensland state service. In this case, it's the cadastral. So what I'm going to do is I'm going to add that parcel position information into my connection into that server. I actually added a few more items in there as well. So what I can now do is make that connection to that Queensland state government server, and I can bring that into my project environment. So in this case here, I've brought in the cadastral. I've also brought in some zone information and some lot information. So again, I'll set that transparency. So once I've got that set in, we can also attach, so that was hooking in through a web mapping service, but we can also hook in or download from these service providers file formats such as shape and tab files. So in this case here, I'm jumping into the NBN. They provide a tab file. I'm going to bring that in and reference that into my project area. Now, when it comes in, it actually comes in, it's all of Australia. So it includes the NBN throughout all of Australia, which is overkill for this particular project. So what I'll do is I'll actually create a polygon here, which is indicative of the area that I just want to show the NBN within. So I can clip all the remaining part of Australia out. So just focus on the area around my project. Now, I've done something similar to all the services I could get hold of, all the utilities I could get hold of, and I'm referencing those all into this master DGN. So within here, we've got a number of services or utilities. For instance, this is the drainage information. Drainage information we're pulling from the Sunshine Coast Council. We've also got sewerage information that we're pulling from Unity Water, the local provider here. And much of this information is, I'm going to say some of this information is survey accurate. You need to be aware though, it needs to be fit for your purpose. So you need to look at the metadata that's associated with this information coming through. I will add though, over the years, this information has become far more accurate than it ever was. I recall back in, when I first started surveying back in the late 80s, we used to call GIS get it surveyed because the accuracy just wasn't quite there for the needs. It has improved vastly. And as I said, you need to determine it's fit for purpose, fit for your project. But there is a lot of information that's freely available out on the web. In addition to GIS type information, there is also terrain-based information that Geoscience Australia freely provides in the form of DEMs and point cloud data for a large area of the populated area within Australia. It is actually called Elvis. And in this case here, in this example I'll run through, I've actually connected into Geoscience Australia and brought down a point cloud. Now, this point cloud data is for a huge area of the Sunshine Coast. It's actually 1.5 billion points of point cloud data. And it consists of, it's classified point cloud data, so it consists of vegetation, ground, buildings, etc. Now, from my point of view, I'm only interested again in my project area. And from my point of view, I'm only interested really in the ground data because I want to be able to extract that ground data to create a digital terrain model. And I want to use that digital terrain model that is outside my project area, but I want to be able to utilize that for other purposes, whether it be for visualization or maybe it's for defining of drainage catchment areas, for instance. So again, I can come through within OpenSite Designer and clip out that area of interest. And that area of interest is confined to in and around my project area and just consists of the ground points. So what I do now is actually create a file, what we call a pod file, a point cloud file of just that area and of just of the ground. So with this next slide, I'm going to pass over to Ty. Ty is also with Air Services Australia Air Inspect Australia, and he's going to step through. He's their chief pilot, and he'll step through these next few slides. So over to you, Ty.
No worries. Thanks, David, for the introduction. So I'm going to break down Air Inspect's capture processes for aerial site survey and mapping. You'll see the 5 planning and capture steps on screen. So first step is planning, which we plan with the customer team. We then go in and put down ground control placement with the customer surveyors. We then set up our base station on a known location. Then we launch our drone and fly our pre-planned mission. Then we land and wrap up on site. So then you'll see our 5 steps for processing and output. So we go through and correct our location data, stitch our photos, align our visualization to a coordinate system, validate our position data with the customer surveyor, and then we produce a visualization. Next slide, please, David. So on screen now, you'll see a bit of our pre-planning processes. So first step we do is go to Google Earth. We look over the operation area just to check if there is any obvious hazards, e.g. power lines, power poles, trees, anything that can get in the way, basically. We then obviously go to the weather, because weather, unfortunately, with drones plays a big part in our flights. So we need to check if there's any wind or rain or any other general weather hazards that are going to stop us getting into the air. We then go through our risk assessment and job safety assessments, or JSAs as we call them. We then go over any risks and hazards that are in the operation area, how we can mitigate them and make it obviously safe for us to fly and safe for the public around us as well. We then usually refer to a visual terminal chart, otherwise known as a VTC chart. We do this to check our airspace, check for nearby aerodromes, helipads, no-fly zones, in case we need to get permits from CASA for the flight of the operation. We then have a look at mobile tower maps. We need to check for nearby mobile towers. They can pose a risk during flight, but as long as we know they're there and we can keep away from them, they're not a problem. Next slide, please, Dave. So you'll see some of the additional pre-planning processes on screen. On the left, you'll see our compliance software. This basically is giving us a bit more information on the airspace and the potential risks in the airspace, such as aerodromes, obviously helipads again, and any other emergencies going on, etc. They're usually all included in these maps. On the right, you will see our job safety assessment checklist, or a JSA checklist that we need to perform before every mission. Some of the things that we go over there to check are, obviously we have permission from the landowners, checking for public moving into the operation area, and obviously our ability to stay 30 meters clear of the public are just some of the things that we have to make sure that we're covered. Next slide, please, Dave. So now we go more into the flight planning. On the left, you'll see our mapping area was just under 36,500 square meters. Our flight time was approximately 50 minutes. We captured 935 photos, and the flight was flown at 40 meters as to avoid any obstacles, trees, electrical poles, power lines, etc. The GSD, which is the ground sampling distance, was 1.1 centimeter per pixel, and it was flown at 2.3 meters a second. Our white balance was set at cloudy to match the weather. As much as this seems like a small thing, this is where people can go wrong with photogrammetry. Selecting the correct white balance helps a lot with exposure and stitching. Our gimbal angle was set at -60 degrees. Our flight plans can be created in the controller for the missions, either on site or prior, or they can be imported into the controller via a KML file. Next slide, please, David. So this is a little bit more of a continuation of our flight planning. You'll see our overlap for both vertical and horizontal is set at 80%. So this is to ensure there is enough overlap to stitch the images and create the visualization. One thing you do need to pay attention to is the boundary when using a 3D grid for capture. Drones need to fly outside the boundary to capture data within the boundary. So this can be edited in the planning to minimize the flight outside of the boundary area of the operation to remove any risk of going over main roads or any other hazards that are in your operation area. To complete the capture, we used a DJI Phantom 4 RTK with a DRTK2 base station. GCPs were placed by a surveyor and the base station was placed on a known point, which you can see in the image on the right. And that is how we end up verifying our data. So issues and challenges with the operation were fairly minimal. Only, I guess, hazard or risk in the area was, pardon me, the Clounder aerodrome was within 5K of the operation area. So to mitigate that risk, we used spotters so that there's eyes on the drone at all times. We flew low as to not be in the airspace of nearby operating aircraft. And we also made sure we were not located within the arrival and departure runways as well, obviously to stay clear of them. Next slide, please, Dave. So this is where you get to see a bit more of the finished product. So obviously the post-flight processing was done within context capture. The end result was a 21 gigapixel model with over 900 photos. Took about 7 hours processing time. Obviously that is workstation dependent. And the output was a scalable mesh exported in 3SM. And on the right, you will see the AT with all the little dots, which were the positions that the images were taken on the model. And the fact that they are all green tells us that this was a good AT to stitch together and there was no problems with the model. Thank you. Thanks for listening. And I'll pass back on to Dave to continue the presentation.
Yeah, thanks, Ty. So what you see down in the bottom left-hand corner is the end result. So that's the scalable mesh, the 3SM, the file format that we produce out of context capture. This file was approximately 1.5 gigs. Now, 1.5 gigs is a little hard to push around to the various stakeholders. So as part of this bundle, we're also offering an option to push the reality mesh into the cloud and provide a web-based viewer where anyone can view it without the need of any specialized software. So in this case here, this is a reality data web viewer. So we've pushed that same project up into the web, up into the internet. We're hosting that through what we call context share. And anyone who's got access to the internet and has permissions to view this can view this on any desktop they wish. So rather than pushing that 1.5 gig file to various stakeholders, we can host that up into our cloud service and people can view it from there. So coming to the total station survey, so given the project and given the fact that a portion of Ulm Street, that road that was on that left-hand side of the project area or to the west of that project area required some reconstruction, it was felt a total station survey was required to, and I'm going to put this in inverted commas, to increase the survey accuracy. So within OpenSite Designer, we provide a survey workflow. And within that survey workflow, we have an ability to reduce, adjust, and map. Now, I would describe this as an office-based workflow, so more of a traditional workflow, out in the field to capture, back into the office to reduce, adjust, and map. As you can see there, we have numerous support for various instrument manufacturers and file formats. We also provide a wide range of survey adjustment support, including least squares and bowdage. And as you can see with the right-hand side image, the top right-hand side image, we also provide extensive mapping libraries, including those that represent 3D features. So I'm back into a new DGN or a new model. And in this case here, I'm going to come to the survey workflow. And what I'm going to do initially is create a field book. So I'm going to create a blank field book. And I'm simply going to call this Ulm Street Survey. Now I've come back in from the field. I've got a raw file format that I've downloaded onto my system. And I'm just going to go and drag that and bring that across and drop it under the Ulm Street Survey field book. And automatically it'll go through and do its reduction, its adjustment, and the mapping, and then present that information more or less dynamically on screen. So in my left-hand view, my top view is my 2D view. And as you can see on the right-hand side, I've got my 3D view. So it highlights all the observations I've taken from the control points. And within the properties, we can go through and have a look at all the various properties, the horizontal angle, vertical angle, slope distance that are associated to those observations. We can also click onto the points and identify the field codes that have been used for those particular points. Now, in addition to mapping the observations out and the features out, it also dynamically creates a terrain model. Now, this terrain model incorporates, at this point in time, incorporates the control points, which is really outside the scope of the survey. I'm really focused on the center line of Ulm Street eastward. Therefore, I don't really want to include those particular points within my terrain model or my tin. So I'm just coming in and changing the properties there to do not include to clean that up. And dynamically, the terrain model updates as we make those modifications. Now, if I turn my attention to the features, we can see this power pole over here. And if we look into the 3D view, we can see that power pole isn't orientated correctly. Now, that could have been orientated correctly in the field, but it wasn't. So what we can then do is come back and select that particular object or that particular feature, and we can rotate that particular feature around. In this case here, it needs to be rotated by 90 degrees to follow the north-south route that that power line's taking. Now I'm going to do something a little funky here. I'm going to bring in the reality mesh that Ty just created, so I can get some idea about the size of this power pole. And really, when we're out in the field, we should have probably used a different field code. I'm going to be lazy here and just scale up the Z to create that power pole as an object that matches our reality mesh, our reality model. So in pretty quick time, we can come through, we can use a number of the editing tools, a number of the analysis tools to generate a topographical survey of the area, including the terrain model that's sufficient for this particular project. Now, I talked about the scalable mesh. Ty went through doing the drone survey and running through context capture, creating that reality model. But what we want to do is we've got a reality model that incorporates the ground, incorporates buildings, incorporates vegetation, etc. But as civil designers and as surveyors, we're really interested in the ground, you know, for volumetric, for cut fills, etc. So we are going to create 3 terrain models. We're going to create this scalable mesh derived terrain model. We've already created the total station derived terrain model. We've already extracted out the point cloud that we want to use to create the terrain model. So in essence, what we're going to do is create three terrain models. The first step, however, is we want to take from this reality mesh, we want to be able to create a terrain model from that. So I've brought that reality mesh in, and I'm going to run through a routine that we call ground extraction, and it's a 2-step process. The first step is to define what we call seed points, and these are in a grid form that looks at basically what is the lowest point within that grid and makes the assumption that will be ground. So a lot of those seed points are actually located at the ground. They're not located on top of the buildings or the vegetation. Now, as the surveyor, you can supplement those, you can edit those prior to moving to the next step, which is basically the ground extraction. Now, the ground extraction will create a point cloud that consists of either ground or everything else but ground. So the red in this case here are ground, and everything else that's not ground is shown in yellow or highlighted in yellow. So that's our vegetation, our buildings. We can even see ties, witches' hats. We can see rugby league posts there. So anything that's not ground is yellow, which we can turn off. And we can now come in and save just that ground point cloud into an independent ground point cloud that we can then triangulate. So we'll go ahead and do that, and I'll just call this Clounder 1 ground only. So this is a point cloud that we can then go ahead and triangulate from. So coming into the terrain tab, I'll come down and create from point cloud, create terrain or DTM from point cloud, give it a name, hit the import. You know, after a minute or so, it'll create this terrain model for me, and I'm displaying the contours. Now, upon investigation, we can see that there's some funky points going on. So there's a couple of things that we could do. We could go back to our seed points, and obviously this seed point is looking at something else other than ground. So we could go back and delete that seed point and repeat the process. Or we do provide some post-processing DTM or tin editing tools that allows us to edit that on the fly or post-process. So I've generated these three models, these three terrain models, one from our total station survey, one from our drone survey. And if I just pause this, if I can find that. Let me see if I can pause this video. And one from the point cloud survey. So in essence, what we have are three terrain models. And if I come back into here, you can see there the three sets of contours that are represented from the three terrain models. The green straight contour is from the total station survey. And the triangulations occur between the two break lines, the center line and the existing edge of pavement, and hence the reason why there's a straight line representative of that particular contour. The highlighted contour is actually from the drone survey. So there's a lot more points that's incorporated into the digital terrain model, and therefore the contours are less rigid. There's more flow to them. Additionally, with the other contour that's shown there that extends to the left out there, that's part and parcel of the LiDAR data from Geoscience Australia, or that point cloud data that we created. But what I want to do now is create what we call a complex terrain model. And I want to use these three terrain models to create this complex terrain model. So I'm going to include my LiDAR only terrain model as the primary, and then merge in my drone survey, and then merge in my total station survey. Go and select the feature definition that I want this to be presented as, name the new terrain model, and then zoom in. So as we can see, we've got one model represented here. That's a combination of those three particular terrain models that we started with, being the total station, the drone, and the point cloud model. So further analysis, further investigation of this terrain can take place using the tools up there. Before signing that off, saying, yep, it's in compliance, it's okay, it's good to go, downstream from us, from the survey world into the design world. However, prior to that, I do just want to touch on a creation of a multi-resolution terrain model. What we still call a scalable mesh, so similar to what we were doing with the drone survey, except this is strictly 2.5D. So all we're doing is the terrain. So we're creating a multi-resolution mesh of the terrain. And what we're going to do here is take that 1.5 billion points point cloud that we obtained from Geoscience Australia, just identifying the ground points, from that, so those classified ground points. And what we're going to do is set up a this multi-resolution reality mesh that's 2.5D. So I'm going to call in that point file, that pod file, and I'm also going to call in the Bing maps because I want the Bing maps actually to drape onto this multi-resolution mesh or this scalable 2.5D mesh. Now this does take some time. It probably took about 20 to 30 minutes to produce, but it produces now this multi-resolution mesh, which provides me far better context for other items I may want to do with my project, i.e. visualization purposes. So I'm just going to turn off that point cloud file. And as you can see, we've got this multi-resolution mesh with the Bing maps draped in. And as I said, it's a big area. It encompasses, probably half the Sunny Coast Council area, and incorporates obviously our project area. So from a surveyor's point of view, we've gone through, we've undertaken a couple of different types of survey, a drone survey and a total station survey. We've got some point cloud data. We're combining that all together to create terrain models and a feature survey and a reality mesh that we're happy with. We've analysed, we've validated and vetted, and given the green light for our design team to start using that. So let's jump into the site-based workflows. And I'll start with that road that I was talking about, Ulm Street, that road that's on the left-hand side or on that western edge there. And we're going to perform some road widening there. We're also going to do that Greenfield road. We're going to do that link road in between as well. And to do that, we're going to make use of OpenSite Designer's geometry tools, its decision-making templates, because from here, what we're doing is we're making real-world objects. And these objects that we're designing have rules and relationships. It has parent and child relationships. So it understands the design intent that the designer is applying to his design process and workflow. Additionally, we also provide, I've got up here intersection macros. We don't call them macros within OpenSite. We actually call them civil cells, but they perform a same role as macros do. So what we'll do is we'll jump into the next session or the next presentation here and run through this. So as you recall, on the napkin, we sort of developed, what we needed to do, Ulm Street, where we thought the link road should go. So I'm in this model, this new DGN, this new model, and I've already placed in the existing center line, the geometry of the existing center line. I'm just simply into Google Maps here looking at Ulm Street, and you can see there's curb and channel on that western edge, but on the eastern edge facing the park, there is no curb and channel. But that's what we need to do as designers. We need to design that curb and channel. It was also decided what we would do is we would offset 2.5 meters from the center line to determine a cut line from Ulm Street. So from Ulm Street center line out 2.5 meters, anything beyond 2.5 meters heading east towards the park, we're going to do some full reconstruction of that portion of that Ulm Street road. So I'm just using some geometry tools here to define where that cut line is, where that join line is, where that edge of full reconstruction is going to take place. It was also decided we're going to do a slurry seal over the top of Ulm Street at 7 mil, so some microsurfacing over the top of Ulm Street. But what I'm doing here is I'm just using the dynamic geometric tools to be able to set in where this cut line is. And I'm just going to call this Ulm Street joint line. So join those particular elements up. And so that gives me an idea of where I need to make the cut and where construction needs to make that cut and where I need to then look at how I design the remaining portion out towards the park. So the first thing that I'm going to do is I'm going to take a look at the profile that's draped itself onto that terrain model, that complex or that combined terrain model. We can see that we've draped that on. We can see that in our 3D view. I'll come to my 2D or my plan view and pop that into a profile view. So in this profile, it's showing me what that terrain model looks like along that cut line. Now, as I said, we're going to do some microsurfacing here. We're going to do a slurry seal of 7 mil. Now, it looks pretty jagged on this edge. You know, the profile view, the exaggeration may be at 5 or 10 to 1 here. So we'll worry about that when we do the next portion. So at this point in time, what I want to do is now establish the new edge of pavement. So what I've done is come into that cut line, offset it by 1 meter, and that now is going to form my new edge of pavement. Now I'm going to come back into my profile of that particular element, and I'm going to clean this up somewhat. So what I'm going to do here is do a best fit through that. So I'm going to do an envelope that's 20 mil above that red line, that, well, it's now blue, and 20 mil below. And I'm going to feed a best fit profile through there. So I'll step through the prompts, and it will feed through this new butte profile that's representative of the edge of pavement for my new Ulm Street. So now I've got, in my 3D view, I've got those strings, those 3D strings that represent the cut line and also represents the new edge of pavement. Now, what I'm going to do initially is I'm going to create a terrain file that just incorporates that portion of the road widening. And then what I'm going to do is actually embed some objects into that. So I'm going to come in and place a template that's indicative of the pavement material that we want for this portion of the widening. Now, because they are objects, they're solid objects or they're meshes, they have volumes associated to it, and they have areas associated to it. So fairly quickly, we can set up that widening. Now, at this point, I'm going to turn my attention to the greenfield portion of the project, this road that extends from Ulm Street over to the east to George Street. And again, I'm just going to come in and use some geometry-based tools. I'm coming in and highlighting the center line of this, roughly where I think the center line will go. And attached to this center line is a template that I want to use for this particular project. Now, at this point, it's gone in, it's designed the 2D strings, and as you can see off on the right-hand side, the right-hand view, the 3D model. Now, this is a first pass, and everything's parametric, so I can come in here and start manipulating, key parameters within this horizontal alignment. For instance, the radius or the IPs. So what I can do is, even once placed, we can go through and start manipulating this alignment, and it's fully parametric. And it's got that parent-child relationship. Now, obviously at the intersections, I want to do something at the intersection. So I want to bring back my template back by about 40 to 50 meters away from those intersections. Now, when we placed in the alignment, it also did a first pass vertical design. Now, as a designer, I want to come in and check that. And obviously, as a designer, I want to modify that. So in this case here, I'm starting to modify the vertical profile, but I'm also conscious of that we're tying into existing pavement along George Street on this eastern edge. And I want to understand where that point is within my profile view. And we get that little purple or pink dot that's indicative of where that join line is and where we need to join in our new design alignment or vertical profile. Now, at this point here, I'm also conscious of the fact that I don't want to have to import material in for cut fill material, and I don't really want to export a lot of cut fill material. So I'm going to come in here and calculate the volume of cut or the volume of fill and the volume of cut. And I'm going to manually iterate my profile to try and balance out that cut and fill. And we're just talking about the subgrade material here. So we're not looking at the base, the sub base of the asphalt. We're just strictly looking at the subgrade material, the cut and fill material. So we can see here I'm within, plus minus 30 meters, which for me is going to be good enough. So I've got volumes of earthworks that I need to move around on my site. But because these are objects, I've also got volumes of material that we need to import in for our sub-base and base material and our asphalt. So once that's completed, I'm going to turn my attention to this intersection. Now, this intersection, if you recall, required some widening. It required a left-hand turn lane. So what I'm going to do is I'm going to come in and use this civil cell or this macro. Now, I don't want a simple T intersection there. I want something a little bit more complicated that's got an island incorporated within it. I'm going to select that and then select some critical, two pieces of critical information I need to be able to configure this intersection. And I'm going to step through the prompts to make sure I get that 2D representation of what I want, looking what I want. Once I'm happy with that, I'll OK that. And it goes ahead now and places in all those objects related to that intersection. And again, they're fully parametric. So we can come in and edit that. If you recall, I moved that template by 45 meters. Therefore, I'm going to move my civil cell or macro back 45 meters so it stitches in neatly. So again, we've got full objects, asphalt, median, concrete, etc., located there. Now, at this point in time, I'm coming back roughly to the center of this link road. I'm looking at that batter slope that extends out to that southern portion there. And I want to modify that batter slope. Now, the batter slope may be at 5:1 at this point in time, so I could steepen that up at 2:1. But what I want to do is actually come in for a length of that, that batter slope, that fill batter slope there, and put in a retaining wall. So I'm going to use an end condition and change this end condition from that batter slope. I'm going to delete that out, and I'm going to come into my library of templates and components, and I've got a retaining wall in there. So within my template view, I'm going to reflect that, place that at the location, hit OK. So automatically it's going to reprocess the corridor, reprocess the model, and place that retaining wall in. And search for obviously existing ground at that point. So pretty quickly we can start developing our design within OpenSite Designer. Now I'm going to change gears here. I'm going to move away from that road design component and look at, that pure site design capability. And we're going to use another capability inside OpenSite modeling or OpenSite Designer that allows us to focus on things like pads, ponds, car parks, things like that. And the way that we approach it within OpenSite is through this phase design approach. And it has 3 phases: conceptual, preliminary, and then final. Additionally, this module also contains a optimization engine for car parking and car parking arrangements. It also includes an optimization engine for earthworks and grading. So let me come into this. So again, the napkin design that we pulled together, someone's kindly provided me with some dimensions of, the clubhouse, the bowling green, the car park. So I've got some dimensions now, which I can draft in as construction elements. So these are just shapes that are representative of the bowling green, the clubhouse, and the car park. That outside square shape is actually limits of disturbance. So when we're doing our earthworks calculation, we're just limiting ourselves within there for cut fill. So the first thing that I'm going to do is I'm going to do the bowling green. And I'm looking at what the elevation is at roughly the centroid point. So I can set this object to be at that elevation, which is 16.8. Now I'm going to use the optimization engine here. And you might be thinking, why are you going to do that? Because I fixed the elevation at 16.8, and you're right. It really doesn't do much because I've fixed it. I've locked it down at an elevation of 16.8. But it's showing me the batter slopes coming off that. But as a designer, I want to see if, I can place some retaining walls along, the eastern, western, and southern edges. So I'm going to put in this link height as NAM, which basically means, when you're doing the grading solver, check to see if retaining walls is going to provide a better solution for me. In this case here, it's reduced the quantity of cut fill material by, I think it's probably by about 700 cubic meters. It's obviously added cost for the retaining wall, but it's reduced those earthwork values down. Now I'm going to turn my attention to the shape that's representative of the car park. Now at this point in time, it doesn't know there is a building pad there, so try and forget about that internal white shape. But as you can see there, as I move this shape around, it tries to optimize the location of the car park, given some initial constraints that we've provided. So in this case here, we can see we've got space count of 176. We've also provided it with some parameters as a default, but you can come in and change those parameters. And again, we're just in the conceptual phase here. So there's a lot that we can do within conceptual phase. That's more of global edits. But let's say I want to actually see if I want to modify that parking arrangement. So I want to put this flow direction arrow in, and automatically it changes the way that the car park is arranged in there. Now, in this case here, I've reduced the space count to 142, which is probably not optimal for what I want to do here, but it's very much dependent on some of the constraints and some of the variables that the site throw up. But here, we can add islands, we can do some modifications to it. Now, what I've done is I've taken it back to the original state that we initialize this car park arrangement. And what I've done is say, look, with this car park, I want to slope it away from the bowling green at 2%, sort of in that northerly direction. And again, we come through and we perform the optimization, which goes through its process. Now, at this point, I've come in and introduced the building pad. And once I've introduced the building pad internally within the car park object, it knows it needs to modify the car parking arrangement. Now, manually, I've gone off to this western edge of the car park and the western edge of the clubhouse, because that is going to be the loading zone. So I don't want car parking in at that location. So using the properties of this object, I can go ahead and modify those. Additionally, I do want a pathway around the perimeter of the building pad. And I'm going to make that 1.8. Additionally, I don't want car park. I want this to be an entry point into the clubhouse. So I'm going to make an apron out here. So just again, using those parameters to define the layout at a conceptual phase of how this looks. So I can go ahead and now I've got these three objects in, I can start grading that. And again, it'll go through its optimization routine in an attempt to find the optimization based on the earthworks. Now, what I'm going to do is actually modify the direction that I want that car park to grade. So we can see those contours now are grading perpendicular to that grade line I've placed in. So at this point, I'm relatively happy with what I've got. So I'm going to take it from concept to preliminary. Now, at the prelim stage, it actually creates terrain models. It actually creates tin models of all those objects. And this just allows me to come in and individually modify components within this, in this case, the car park. So I'm going to change that from a 1 to a 2, and I can do that for all those particular parameters. So I'm happy with this. So I'm now going to take that to final. So once I take it to final, it actually creates objects for me. So it actually assigns objects that are associated to the car park, the building pad, the bowling green, etc. Now, if you recall at the conceptual design phase, I said, look, let's see what it looks like with retaining walls. So I'm going to just design that in the final and put those retaining walls in. So at this point, I've completed the project. I've actually done the access road into the car park. I've brought in the architect's DWG representation of the clubhouse as well. So I've done a little bit more extra work there with joining the link road to the car park. But at the end of the day, we've come up with a relatively good design that we want to start moving forward. At this point, I want to engage with the drainage engineers and the drainage team, because I want to now perform some drainage design over this site. Now, within OpenSite Designer, we also have a workflow. We've got a survey workflow. We've also got a drainage and utilities workflow. And the capabilities in there allows us to perform, steady state hydraulic design and analysis, so using the rational method. But we do also support that unsteady state hydraulic analysis. So, we've got, the swim engine can be deployed if need be. We also support Australian Rainfall and Runoff 2019, so the ensemble of rainfall temporal patterns. We also provide within the workflow and within this particular module within OpenSite Designer, we also provide culvert design and hydraulic analysis of water sensitive urban design, or we may know it as low impact development. And as you can see, we also create 3D objects that represent the drainage network. We also provide utility design, layout and modeling, so of your sewer, your electrical fiber, gas, telecom, etc. So in this next session, what I've done is I've developed up a further terrain model. So this terrain model is a combination of the design with the existing. So we can see here we've got this model, and first thing that I want to do is actually come in and interrogate and analyze this model from a drainage perspective. So basically what I'm doing is pouring an endless bucket of water on the ground at that location and seeing where that runs, just so I can get an appreciation of what's going on this site. So for instance, on this southern side, I pour that bucket of water and I can see that it actually ponds around that curb return leading into the car park arrangement. But I can also now identify that ponds, and I can identify the volumes and the depth of that ponding that's going to take place at that point. Just again, to provide me context of where I may need to lay in my nodes or my pits or inlets, etc. So I'm going to go ahead and do that now that I've done that. So I'm going to come into the place node routine, and I'm going to identify the fact that I'm placing nodes along the gutter line. So the feature definition for the catchment will be a pavement. I'm going to go through and select the type of gully pit that I want to put in place here from a library. I'm going to select that tangent point at that curb return, reference it to the alignment. And you can see in the 2D view, it automatically creates the catchment area that's going to be servicing this pit. Now in the 3D, it creates the model it places in that model. So we're designing in 2D and it's automatically modeling in 3D for us. So again, I'll come to the other side and I'll place in that pit location. And again, you can see that it defines the catchment area that's going to service that pit. Now we do have a number of default design constraints for your pipe. So your velocity minimum, maximum, your cover minimum, maximum, slope, etc. These are pre-cooked or predefined, which you bring in. So these are, let's call them preliminary design constraints, because we haven't done any hydraulic analysis at this point in time. We're just laying in initially the pits, and then we're going to join that up with pipes. So I'm going to come to my library, my feature definition, identify that I want to use some Humes concrete pipes, 375. I'll put them in initially at 375. Hydraulic analysis will update those once we get to that point. Now, we were doing those individually, placing the pits, placing the pipes. We have got a routine that'll go through and automate that. We go and select that, that gutter line. It'll go through now and place those pits at a predefined, or in my case, I think I made them 35 meters apart, and join those up. Now, once they're in there, you can modify them, you can move them. And again, they're fully parametric. They understand that, they should be perpendicular to the control line, which is the center line, so they'll adjust accordingly. And I like placing these roughly at the tangent points there. Now, with this straight piece of pipe, I don't really want that. What I would like to do is introduce a bend into it. So I'm going to introduce a bend, and I'm going to bend that pipe. And you can see the segmentation of the pipe, and they're at that 2.44 of that 8-foot interval that represents the individual pipes. So once you've gone through, you've laid out your pits, your pipes, and your catchment areas, we want to now come into the hydraulic analysis. And let me just pause this if I can. And within our drainage module, we've defined within here an ability to set up scenarios. So in this case here, you can see I've got two design scenarios, one at this 9.49 ARI and one at 20. And then I've got an analysis at 50 and 100. So basically what I'm going to do is I'm going to design this for a 10-year event. So I'm going to design the system for a 10-year event, the pipes, the pits, and that will modify to take into account those design constraints, but also the hydraulic requirements for this 10-year event. But then what I can do is then go back and say, okay, given that design of that drainage network, what happens if I get a 100-year event? What happens to my network? Does it fail? Where does it fail, etc.? But first up, what I'm going to do is step through the design process. So I'm going to set that to, with the red tick mark to say that's going to be the active one. I'm going to go ahead and design that. It's going to go through that entire network and modify that network according to the hydraulic calculations that it's performed. So these pits in the bottom right-hand corner of your screen in the 3D view, you'll see that they've dropped down. We'll see that some of the pipes have actually increased. During the process, it does come back with some warnings saying that, the minimum TC hasn't been applied. In this case here, some of the on-grade inlets, the efficiency does not meet minimum constraints. This particular pit at a sag, the spread is beyond the threshold that we've already nominated. So there's a number of warnings in there. But one of the things I want to do before I start looking at addressing some of those warnings is I just want to come and review the network. And one of the things I probably want to do is define the profiles. And there's, a multitude of profiles in here. So what I'm going to do is come to my profile runs and actually get the software to define where those profile runs are. So I'm going to select the outlet, which is into my pond at this bottom left-hand corner. And it's going to go through and identify that there's probably 10 possible profiles. Some of these are, the road crossings, but there is a list of profiles that's been automatically generated for me. So I'm going to come down and look at one of these profiles, and we offer 3 options for profile modeling. This is our analytic profile modeling. In this case here, I'm looking at my network at that 9-year or that 9.49 ARI. And it seems to be, with the hydraulic grade line and the EGL, the energy grade line, it looks okay. So we can go through and analyze the effectiveness of our initial design. We can come in and tweak conduits or links or pipes. We can fix invert levels if need be. For instance, the outlet is a fixed invert level into the pond. But what I want to do now is I want to come in and analyze how this is performing if we get 100 year. I should have done it for 500 year because apparently that's what we had last weekend. So what I want to do is analyze how this network will perform with this 100-year event. And you can see that the hydraulic grade line and the energy grade line has increased or risen up. It's changed, but it still seems to be working okay. So given that, we're going to move forward with this drainage design. This drainage design might take a couple of days, and we're trying to roll this all into 10 minutes. But we've identified that pit that flagged to say that, the spread width was beyond the threshold, the minimum threshold. And one of the things that we could do in there is highlight that particular pit, and we might want to swap that out. We might put a double pit in there. We might do something that allows us to take that water into that pit a little bit more effectively. This is probably outside the scope, but we also, well, not the plants production capabilities, obviously that's not outside the scope. So we do provide that full range of plants production capabilities. We do provide comprehensive pond routing, design and analysis capabilities. Now this may be outside the scope of what we're presenting today, but rest assured it is part and parcel of the drainage module. So we can perform that type of analysis and design as well. In terms of miscellaneous capabilities, I've probably shown throughout the course of the presentation the various quantities calculation capabilities, whether that's materials, earthwork volumes. We do provide mass haul diagrams, and again, that might be outside the scope of what we're talking about here for smaller civil type projects, road projects. It is DE ready, so it's digital engineering ready. We provide what we call an asset manager that allows us to tag or associate extended attribute information to all these objects. We also provide in product a clash detection capability, and I call it interdisciplinary. I don't like calling it clash detection. I like calling it clash prevention. So when you're in design mode, you can actually perform your clash prevention or clash detection within the product itself. So it may be from your drainage network to the existing services or existing utilities that you've also mapped in. Importantly, we provide plan production and digital delivery capabilities. It must be noted that what we're offering today includes an embedded CAD engine, i.e. MicroStation. So you've got that full access to those full capabilities that come with MicroStation. Now that next point there, all derived from 3D models. If we take a look at the cross sections there and we look primarily at the terrain shown in green there and the design surface, don't worry too much about the frame and the annotation underneath that at this point in time. But the explanation here is that that representation of those cross sections actually is a very small slice through the model. So what we actually do is slice through the 3D model to be able to obtain those cross sections and profile views. So if the model updates, those cross sections update. Now, you will at this point in time, you'll need to rerun the annotation. You just need to refresh the annotation so it picks up the new elevations and that. But the terrain information dynamically changes because it is all derived from the 3D model. Now, I've spoken about some of the in-product reporting capabilities. We have a host of outputs that we can derive in terms of bill of materials, volumes, alignment details for set out, etc. Last but not least is cinema quality visualization capabilities. So here's my design. And what I want to do now is I actually want to turn off my Bing Maps and I want to bring in my drone survey. So this is my original drone survey that I've brought in. And what I want to do is now is come up into OpenSite Designer and come to the visualization workflow and push this out to LumenRT. Now, LumenRT provides a cinematic quality real-time rendering engine. So that's what the RT, LumenRT, the RT is real-time. So in this case here, I can zoom around the model. I can set the environment within the model, the time, the location on a map, the coordinates that we're sitting at, the date, the season, the clouds, whether it's blue sky, it's clear, it's hazy, etc. We can even do the speed within the trees, so wind in the plants. So if I make that windy, and talking about vegetation, I can come in and enliven this model up with extra data. So for instance, the landscape architect may suggest that what we want to do is place in some vegetation around the clubhouse. So in this case here, not that you would go and place in that mature tree, I wouldn't have thought, but what we're highlighting is the fact there is a library of vegetation that we can bring across and into the cinematic quality model. For instance, at the back here between the houses and the bowling green, as a screen, we might want to place in some mature jacarandas, acting as a bit of a screen between those houses and the bowling green. Additionally, we can come in here. We can place some people in here that are, at the bar, at the clubhouse. So there's a bunch of stuff that we can do that allows us to what we call enliven the scene. Let me just fast forward that. And what we can do is we can make, those cars and the buses and things like, and the people, we can make them mobile. Determine a path that the cars are going to apply themselves within, and run that in real time. So at this point in time, what we can do is bundle this complete model up as a .exe file, and we can send that to any of the stakeholders. And if they can open up an exe file, if they've got permission to open up an exe file, they don't need any other software. They can fly through this. They can walk through the bar area. They can walk through the clubhouse. They can view it as I'm viewing it here today on their desktop. Additionally, we can present in this case, an MP4, a video of the proposed development within this project area, showing the road widening, the left-hand turn, the link road, the bowling club, the bowling green, the car park, etc. And we've brought in that extended Sunshine Coast multi-resolution digital terrain model to provide some broader context to where this project is situated in relation to the CBD of Caloundra, relation to the golf club, etc., etc. So this is an MP4 video that we can produce, and again, that can be used for stakeholder engagement. So taking it from that napkin design, sort of working through the process within the time allocated, getting it to a point where we can produce that final model and that final visualization. So just to summarize, so the survey capabilities that we provide within this bundled solution, this bundled offering, supports various survey sensor types and source types, including digital photogrammetry and point clouds, total station and GPS sensors, ability to link into that GIS data and stream or import that into your project workflow, providing that extensive terrain modeling and analysis capabilities, including support for that complex terrain type environments, and as you saw, with big data as well. In terms of our site design capability, as you saw, road design, site design, drainage design. I didn't go through the services and utility design through videos, but it's a similar workflow to what we presented in terms of the drainage. Something I didn't show is the geotechnical data support. So there is a module or workflow within OpenSite Designer that supports that geotechnical data. So creation of subsurface terrains, borehole logs, etc. As I mentioned, built-in CAD capabilities, MicroStation is provided as part of this offering, and cinematic visualizations. So with that, that's why we believe that we've brought to market this bundled solution does provide the most complete survey and site design solution within the ANZ market. So at this point, I'm going to ask my colleague, Mike Mahdavi, to provide some further detail about the special offer. Now, Mike is our local product sales engineer who has brought this bundled offering together. So with that, over to you, Mike.
Fantastic. Thanks, Dave. That was quite comprehensive. All right. As Dave mentioned, we do have an offer today, and the offer includes a bundle of context capture and OpenSite Designer. If you could maybe move to slides. Fantastic. So yeah, this is a bundle of context capture and OpenSite Designer just for over 5K, and this is a yearly subscription license. And that cost, the cost includes training as well. So training is included, 12 hours of training, 6 hours for context capture, and 6 hours for OpenSite Designer with one-on-one training with a Bentley expert. So please do reach out if you're interested. We do have free trials as well. You have my contact details there, and yeah, any technical questions as well, please do send through if we don't get to them in this session. Fantastic. So with that, before we move on to the questions, we do have a poll question. If Claire could help us with that. Amazing. So we're going to just keep this up for a few seconds before we move on to the questions. Great, just a few more seconds. Please do put your questions in the Q&A box as well. And we don't have much time, but we'll get through them as much as we can in this session. Fantastic. So first question coming through from Brian. I guess this is directed to you, Dave. Are all feature codes attributes picked up by OpenSite, or is there any additional customization required?
So it's a combination of both. So what we've done is we've supported a number of state government authorities and state government or state-based objects. Now, at a local government level, they may need to be modified. You know, some of the curb profiles, even though they're extensive, they may need to be tweaked for localization purposes. So we do provide, you know, a library of objects. However, there is an ability to customize your own as well.
All right, fantastic. Second question coming through from John. John is asking, is LumenRT a separate software or is it included? So Lumen, everything that Dave showed today is can be accomplished with this bundle. So LumenRT is also part of the bundle. It's not a separate software. Fantastic. Next is from David. Does photogrammetry process support PPK type surveys?
Yeah, it does. So, you know, Ty and the team, they used RTK with their survey, but it does support PPK. Context capture, that workflow within context capture supports PPK.
All right, fantastic. Next one from Matt. Matt is asking, does the drainage module support culvert design and does it analyze gutter spread width?
Culvert design, yes. So the answer there is yes and yes. So we ran out of time, but yes, it does provide that culvert design analysis capabilities and also the gutter spread width. We actually, that's quite new addition actually, where we're showing that spread width in the plan view. So we're graphically representing where that, that spread width is. And we're also showing it within a table view as well.
All right, fantastic. I think it's been a very long session, so we'll just wrap it up here. Amazing. Thank you everyone for attending today, and stay safe and dry, and hope to see you in our next events.
Yeah, thanks everyone. Bye for now.